Good morning, everyone. Good morning, ladies and gentlemen. So today I'm going to share to you part of our study funded by the DOST NRCP and implemented by Ray Labs at MSU at Naawan. It's entitled Quantifying Microplastic Presence in the Waters of Gingoog River. Now, yours truly, I am Shirley Anti Inocente from the College of Agriculture, Forestry, and Environmental Studies. The contents of this presentation is of course the rationale, our study area, the methods that we have used in the study, the results, and of course our conclusion. Plastic pollution is a global problem as a result of the explosive development in plastic manufacture and usage. It made a popular increase in the 20th century, and their manufacturing is still increasing now. Plastic pollution has been found to severely impede economic activities like fishing and tourism, to obstruct transportation over and along a river, as well as in some locations, it endangers the availability of clean fresh water, endangering the financial security of the communities that depend on and live next to the river. Now, global concerns about plastic trash, both microplastics and macroplastics, require immediate attention and reduction. Despite varying numerical estimates, land-based sources account for the majority of plastic that ends up in our rivers and oceans. Through accidental release and indiscriminate dumping, plastic waste has accumulated in the environment at an uncontrollable rate. And please note that plastics don't biodegrade. Instead, they disintegrate. And when this plastic waste enter into a body of water, their rate of breakdown accelerates. And this degradation can create chemical hazards for aquatic wildlife. Plastic additives are also leached into the environment, and the disintegration of plastics can cause harm in the gene level up to the community level of this species. This study was conducted in Odyongan River, located in Gingoog City, Misamis Oriental, which is a stream in northern Mindanao, Philippines. The Odyongan River is a vital freshwater resource supporting agriculture, fisheries, and biodiversity. It plays a key role in sustaining local livelihoods and contribute to the health of Gingoog Bay, where it drains. However, environmental challenges like deforestation, pollution, and sedimentation threaten its ecosystem, emphasizing the need for sustainable watershed management. So this is a map of Odyongan River, Gingoog City, Misamis Oriental. As you can see, we have 7 points strategically located at the different parts of the river. Now, point 1 and point 2 are located in the mouth of the river where it drains into Gingoog Bay. Gingoog Bay, which is located in northern Mindanao, Philippines, is an ecologically significant area within the Bohol Sea. It supports diverse marine ecosystems, including fish, mollusks, coral species which are essential for the ecological balance and local livelihood. However, again, it faces environmental threats like overfishing, habitat degradation, and it emphasizes the need for sustainable management and conservation efforts because the bay plays a crucial role in maintaining biodiversity and serves as a focus for scientific research in conservation, pollution, particularly in microplastics. So for our methodology, water samples were collected in the river and we did an on-site sieve method. At the same time, we did on-site preservation with the use of aluminum and glass containers, not plastic containers, to avoid contamination. Now, after the preservation, we transport it to the laboratory. As for the extraction, we do 3 sets or 3 steps. We first do the sample treatment. After the sample treatment, we do the digestion with the use of alkaline digestion. After the digestion, we do a density separation with the use of NaCl. Now, after the extraction, we do the isolation with the use of microscopes. So we handpicked every microplastic, suspected microplastics, and mount it in a glass slide. After that, we do characterization and identify its shape or morphology, further identifying its color, and with the use of ATR, FTIR, we identify its polymer type. Now, after doing the laboratory analysis, results reveal that all water samples collected in Udiongan River were contaminated by microplastics. There is a total of 11 microplastics found extracted from 140 liters of water we have collected in Udiongan River. Now, the most abundant microplastic found was what we call as the fibrous microplastics. Now, these microplastics or fibrous microplastics are often the most prominent type of microplastics found in various environments due to several reasons. Now, first is sources. Fibrous microplastics primarily originate from synthetic textiles like polyester and nylon, which shed during washing. Now, these fibers are released into the wastewater and can eventually enter aquatic ecosystem. Second reason is entrapment. Because of the nature of the fibrous microplastics, it makes it easier for them to become entangled in aquatic vegetation, sediments, and marine organisms, contributing to their prominence in environmental samples. As for the color, we have identified 4 colors present in the microplastics of Udiongan River. Now we have black, blue, transparent, and yellow. And as you can see in the graph, the most prominent color is color blue. Now, color blue microplastics are frequently sourced from microfibers shed from synthetic textiles, fishing nets, and ropes. We also have black, often from tire wire particles, fragments of black plastic products, and degraded plastic items. Transparent and clear microplastics often originates from plastic packaging, bags, and bottles. Now, after the identification of the morphology and the color, the suspected microplastics were then subjected to ATR-FTIR for the identification of its polymer type. Now, we have identified 4 different kinds of polymer type present in Udiongan River, in the waters of Udiongan River. It's polyester, PP, or what we call as polypropylene, rayon, and Aslon. Now, among polyester, rayon, polypropylene, and Aslon, polyester is often the most prevalent microplastics in river water samples, and it goes the same in Udiongan River. This dominance is due to its widespread uses in textile, clothing, and industrial applications. Fibers from washing synthetic fabrics frequently enter water system through, again, wastewater discharge. Its persistence in the environment and the buoyant nature also make it prone to the accumulation in aquatic ecosystems. As you can see in the other picture, we have an example of a spectra we have identified in the ATR-FTIR, as well as the photographs of microplastics we have identified under the microscope. Now, results reveal that the microplastic density of water in Udiongan River is equivalent to 0.08 items per liter. If we compare it to other studies conducted in different parts of the world, it is comparatively lower. As you can see, it is comparatively lower than that the study of Meramic River in which they have 3.6 particles per liter. Now, it's also comparatively lower than that of our other site, which is in Pianing Bridge, Butuan City, which has 0.73 items per liter. Microplastic pollution, or plastic pollution in general, needs monitoring in rivers as it is critical for agriculture because water quality directly affects irrigation systems and crop health. Plastics, particularly microplastics, can absorb and carry harmful chemicals like pesticides and heavy metals, which may contaminate irrigation water and lead to soil degradation. And over time, this pollution can reduce soil fertility, hinder plant growth, and potentially introduce toxins into the food chain. And furthermore, rivers polluted with plastics can disrupt local fisheries and aquaculture, both of which are often linked to agricultural communities. So, monitoring plastic pollution ensures that water resources remain safe and sustainable for agricultural use, safeguarding food security, and protecting livelihoods reliant on farming. Despite the limitations, the findings of this study present a crucial evidence of microplastic presence in the water of Odyongan River, and this may provide a basis for plastic management strategies and intervention to mitigate microplastics, even macroplastics, entry into Odyongan River and eventually in Gingoog Bay. These results will be of use to local government units, the Department of Environment and Natural Resources, BFAR, and other concerned agencies for rigorous and subsequent monitoring of the condition of Odyongan River. Unfortunately, plastic is an integral part of this modern society. Microplastic accumulation is a result of decades of indiscriminate dumping of plastic wastes, and the problem on plastic is a multifaceted problem. Now, what can we do? Of course, we can first act on our level, apply what we know, and furtherly, we can raise public awareness and encourage further studies when it comes to the plastic pollution in our environment. So, I think that would be the end of my presentation. I hope you have learned something, and good morning again and have a good day.